Triangles are going to be a shape that shows up over and over and over again on the ACT. It's pretty much the favorite shape of the ACT. And even when we go into things like circles and polygons and even our three-dimensional shapes, triangles a lot of times are going to be what you break those shapes up into in order to solve. So everything about triangles is incredibly important. So let's go ahead and start off with the basics of triangles. Alright, I went ahead and I drew two different triangles at the bottom of the screen. So on the left you see a right triangle, which is what you're going to be using most of the time on the test, especially if you're drawing your own triangle. It's pretty much going to be a right triangle because there's a lot more that you can do with a right triangle. But the other triangle we're also going to use to demonstrate a couple things. So first things first is the sum of interior angles. So if you guys were just listening to the angles problem that we did, we actually used this rule. So sum of internal angles in a triangle is always going to be equal to 180 degrees. So for instance, in this bottom left triangle, if we're looking at this, we know one of the degrees is 90, and then let's say this is 40, and this other one is 50. So if you add up 90 plus 40 plus 50, you end up getting 180 degrees. Okay, and that goes also for the triangle at the right. Same exact thing, you just add up the interior angles, which means if you know two of those angles, you can always find the third by just setting all three equal to 180 degrees. Next thing to know is the area formula. So in any triangle, the area is going to be 1/2 base times height. Now in the left-hand triangle, that's really easy. Base is just the entire bottom of the triangle, and height is the side of the triangle, the non-hypotenuse side. But in this other triangle, we're going to have to go ahead and drop an altitude. An altitude, same exact thing as a height. So that's going to be your height, and then you have your base. So an easy thing to remember is when you're looking at base and height of a triangle, they have to meet at a perpendicular angle. Otherwise, it's not the height. So if you see anything that's slanted, aka it's less than a 90-degree angle, that's not actually the height. So you always have to drop an altitude if you're not dealing with a 90-degree or right triangle. Alright, next thing is sum of external angles. Okay, before we figure out the sum of external angles, let's just figure out what an external angle is. So I'm going to go ahead and use the triangle at the right for this. So an external angle is basically if you were to extend the line that the triangle is sitting on, then you would have an external angle. So here is an external angle. In order to find one external angle, there's two different ways actually, and it's pretty cool that you can do this in two different ways. So let me go ahead and mark this up for you guys. Alright, to find external angle, all you have to do is either say, okay, that's 180 minus x is equal to your external, or you also could say that your external angle is equal to, in this case, y plus z, but it's equal to the two opposite internal angles. You can find your external angles either of those ways. It doesn't matter which way you do it. Either way is totally fine. But you'll find that, if for instance in this one, what y and z are equal to, you have your external angle. It's easy. If you have x, then you can find it that way as well. Either way is fine. Alright, so sum of external angles, that would be if you have three external angles. So for instance, we have external angle, let's call this 1, then this one would be external 2, and then we would go ahead and use this next one, not quite a straight line, but forgive me for that, as external 3. So 3 external angles. So the trick here is when you add them up, they're always going to equal 360. And there's a lot of different ways of kind of conceptualizing that, but the basic idea is if you add all these angles up, they actually are forming a circle. So in blue, I went ahead and I drew what that looks like. So external angle 1 is E1 in the figure, then E2 is our next external, and then E3 is our last one. So all I did is that I had all of them share this vertex point in the center, and you can see that the angles form up to be equal to a circle. Now, if you ever forget that rule, you can always just add them up. The other thing you can do also is realize that, okay, each one of them is 180 minus one of the angles in the center. So when you have 180 plus 180 plus 180 minus all the angles in the triangle, that's 3 180s minus 1 180, or 360. Okay, let's go ahead and move on. Okay, there's a few more little kind of basic concepts to cover before we delve into the special types of triangles. So the first one is that anytime you have a large side, it's going to be opposite a large angle, and vice versa. If there's a smaller side, it's going to be opposite a smaller angle. So for instance, let's go ahead and make a triangle that has one huge side. All right, so in this triangle, and forgive that it's kind of sad looking, the smallest side is x. The smallest side always is opposite the smallest angle. So smallest side is opposite angle y. The biggest side, which is, let's say, z, is always going to be opposite the biggest angle. So the biggest angle here is angle q. So big angles have big sides across from them. Small angles, small sides across from them. So you can always tell the relative order of the sizes or angles in a triangle if you have either sides or angles in that triangle. Okay, the next thing is that if you have, it's kind of delving into isosceles and equilateral a little bit, but let's go ahead and look at this. If you have, let's say, x and x are both equal sides, that means that the opposite angles have to also be equal. So equal sides, equal angles. All right, let's look at triangle inequality theorem for a second. Okay, triangle inequality theorem is something that you don't run into all that often on the test, but when you do, it's very nice to know it, because your only other option is to kind of play around with the numbers, which works. And again, going back to those cheaty methods, sometimes that's actually the best way to do things. But it's a lot nicer to know what the theorem is so that you can quickly figure it out. Okay, triangle inequality theorem states that every side of a triangle must be greater than the difference between the other two sides and less than the sum of those same two sides. So for instance, using a 3, 4, 5 triangle, because we know that that works, and you can check it with Pythagorean theorem if you'd like, we have to determine if this is a real triangle by triangle inequality theorem. So all we would have to do is pick a side. So let's say 3. So let's go with 3. So this is the side that we're going to be working with. So to check that this is in fact a triangle, we need to look at if 3 is bigger than the difference between the two sides. So 5 minus 4 equals 1. And 3, yes, is bigger than 1, so check. And then the other part of it is if 3 is less than the sum of the other two sides. So 5 plus 4 is equal to 9, and 3 is definitely smaller than 9, so check. So if you're trying to figure out if a triangle was actually a triangle, all you'd have to do is you look at each of the sides individually and you go through and check. So we could then look at our other sides as well, just to make sure. So then if we use 5, we would say, okay, 5 has to be greater than the difference. So 4 minus 3 is equal to 1. 5 is definitely greater than 1. Great. And then also 5 has to be bigger than the sum of the other two sides. So if we add up 3 and 4, we get 7, and 5 is less than 7. So check. And then you could keep going and do that for 4 as well. Let's go ahead and do a problem using triangle inequality theorem because it's one of those things that you probably haven't spent very much time in any geometry class, and it can definitely save a lot of time if you know the theorem. Okay, let's say we have a problem like this one. So one side of a triangle is 9 centimeters. Which of the following could not be the perimeter of the triangle? Alright, first things first, since this is a geometry problem, it's always nice to have some sort of figure. We don't know exactly what kind of triangle this is, so I'm just going to draw kind of a random generic triangle. Okay, and I will label one of the sides 9. All we know is one of the side lengths. We don't have any information about the other side lengths. So this isn't a problem where you can use knowledge of isosceles or equilateral triangles, which we'll get to in a second. It's a problem where triangle inequality theorem is really kind of your best and only real option. So remember, in triangle inequality theorem, every side of a triangle must be greater than the difference between the other two sides and less than the sum. So if we're looking at our other two sides, let's say they're x and y, we can use triangle inequality theorem to try to figure out what x and y might be. So first things first, we know that 9 has to be greater than the difference between them. So let's say 9 is greater than x minus y. And we also know that 9 is going to have to be less than the sum of them. So 9 has to be less than x plus y. Okay, so next step is trying to figure out how that's helpful to us. It's a really simple trick, really, because right now we've got 9 is less than x plus y, which doesn't look all that useful, but let's just rearrange it to x plus y has to be greater than 9. Okay, great. So now at this point we know that our perimeter at the very least is going to have to be 9 plus 9 point, let's say 0.00001. So we know that our perimeter has to be bigger than 9 plus 9. So that means it has to be bigger than 18. Great. One of those answers is smaller than 18. So A doesn't work out because of triangle inequality theorem, because 17 is simply not bigger than 18.